Hi guys, I just thought I needed to speak to you today about ratio and proportion, and about some of the things this important little ratio does for us. And the important little ratio is 1 to n, so that's where I'm going to start. We've looked at ratios before that end up in 1 to n, and I call this a unitary ratio because whenever you've got a 1, that's a unit. Now in primary school you used to do hundreds, tens and units, and that was really hundreds, tens and ones. So how many ones you got is how many units there are, and that has been changed to hundreds, tens and ones a lot just recently. Now it allows us to compare whether two ratios are the same. So for example, if I had the ratio of 5 to 12 and the ratio of 4 to 10, are they the same? Well, if I convert them down to 1 to something, I'm going to divide this one by 5 to get it to 1, and 12 divided by 5 is 2.4. On the next one I need to get to 1 here by dividing by 4, and if I divide 10 by 4 I get 2.5. So you see they're not the same. So they're not the same ratio. Now if I looked at two different ones, so for example 4 to 10 and 10 to 25, again if you boiled those down to the unit, so divide by 4 in this one, I get 1 to 2.5, and then divide by 10 in this one, and I get 1 to 2.5. Now they have the same unitary ratio, and we would say that these two ratios with each other are in proportion. So when two ratios can be boiled down to the same unitary ratio of 1 to something, then we would say that they're in proportion. Now, proportion questions are quite interesting, and an example of a direct proportion question would be something like if 5 pencils cost £1.25, what does 7 pencils cost? An instinctive way to do this is to say, okay, I need to find out what 1 pencil is. So 1 pencil, clearly I'm going to have to divide this price by 5. 5's into 125 pence. Go no times, remainder 1, into 12 go 2, remainder 2, 5. So that's 25p per pencil. And obviously then for 7 pencils, you would do 7 times 25, get £1.75. Now you can break that into a unitary ratio type question. I'm going to do exactly the same thing as I've done here, but I'm going to do it in like a more formal way using this type of writing. So for example, what I'm going to say is 5 to 125, and I'm going to divide by 5 to show that that's 1 to 25. Then I'm going to times by 7 to give me that 7 to 175. Okay, so that's the same problem, just written slightly differently, slightly more formally. And I think it saves a lot of hassle actually. I think that's neat to do it that way. It's called the unitary method of solving questions, and you find the unit ratio. So remember the unit ratio here, unit ratio there, and then use that to multiply up. And one thing I also wanted to discuss about ratios was the order. Now, I'm going to say the order is important. So for example, if I bought 5 guitars and that cost me £500, when I break that to a unitary ratio, that would say that on average each guitar costs £100, which I'll be dividing by 5. Now if I'd made a mistake and wrote that guitars and cost, and I'd accidentally wrote it this way, you could see that when I divided by 5 this time, I would get 100 to 1. Now what I get here is that one guitar costs £100. But what I get here is I get 100 guitars for £1. So this one means that a guitar costs £100. This one actually means a guitar costs a penny. So you can see the order is very, very important. You have to make sure that when you're reading the question, you put the numbers down in the order that they come in the question. And that's really key. Right, finally, what I finally wanted to look at is that sometimes we get presented things in a table and asked, are X and Y in proportion? And I might have 2, 3, 4, 5. And this one might be 20, this one might be 30, this one could be 41, and this one could be 53, for example. So if I take each of these as a ratio, so that's 2 to 20, so I'm looking at the ratio of X to Y, I can say that this one breaks down as a 1 to 10 ratio. This one is 3 to 30, and again that breaks down to a 1 to 10 ratio. Now this one is 4 to 40, 41, which is 1 to 10.25, and this one is 5 to 53, which is 1 to 10.6. Now if we were looking at something that was in perfect proportion, all of those values, all of these unitary ratios would be the same, but they're not. They're not the same. So not in proportion. And that would be it from a mathematician's point of view. But I would imagine that if you were doing a science experiment and these were your results that you were coming out, my science teacher head on me says, actually they're really close, allowing for experimental error. So I might say in a science lesson that they were in proportion and they were following a similar pattern. But from a mathematician's point of view, they're not exactly the same. So we would say that they're not in proportion. So coming back to just recap quickly, the unitary ratio, the 1 to something, way of writing something is really important. If I can boil every ratio down into a 1 to something, I can make comparisons between the ratios. For example here, 5 to 12 and 4 to 10, are they the same? It's really hard to tell until you break it down into a 1 to 2.4 and 1 to 2.5, and you can see that they weren't the same. And on this one, 4 to 10 and 10 to 25, because they both break down to 1 to 2.5, they're in proportion. A proportion question, a direct proportion question, find out what 1 is and then multiply up. So here, find out what 1 is and multiply up. So that's the unitary method. I'm quite happy whether you can think about this logically, or you'd want to use the quicker method here. So either one of the two. Again, just illustrating in this one, order is important. And here, if you're given a series of values and asked, is this varying at a constant rate, is really what we're looking at in terms of proportion. We want things to be constant. If they're varying at a constant rate, so every time it's 1 to something, 1 to something, and that something is always the same, then they would be in proportion with each other. Mathematically, these weren't, but they weren't far out. So as a science teacher, I might say, actually, they were pretty close. Okay, so hopefully you've enjoyed that little introduction into proportion, and I hope to see you soon. Thank you. Goodbye.